Hi, and welcome to the video of Taiwan Semiconductor, explaining the benefits of the TS19503, a DC-DC converter optimized for lighting applications. The product is automotive qualified, but there are also a lot of non-automotive applications for the TS19503. In this video, we will cover the benefits in both applications. The datasheet analysis, discuss the thermal performance, dimming and EMI. At the end, we will also discuss some of the support tools available. Let us look at some of the basics. It is a step-down converter that works in continuous conduction mode. It has an internal 200 milliohm FET that can handle currents up to 2 amps. It provides a plus-minus 2% current accuracy, and it can work up to 1 megahertz. Depending on the configuration and the input-output voltage difference, it can provide output power up to 25 watts. The product is housed in an MSOP10 package with exposed pads. Most pins will be familiar for a buck converter designer, with the LX for the drain of the internal switch and the VD for the internal 5-volt supply. Now let us look what is specifically automotive. You'd expect the TS19503 to be automotive qualified, as per AEC Q100. But the part is also designed on a 75-volt CMOS process. It will work well in car and truck applications that have low dump protection. It has high side current sensing. And it has a dedicated fault flag that will give system information back to the microcontroller in case of an overtemperature and open load event. Here you can see the basic circuit diagram with the high current sense resistor, high side current sense resistor highlighted in red. Over temperature protection has 170 degrees C to 140 degrees C hysteresis. Dedicated fault flag interfaces with the system microprocessor. The device has a well-designed reference, remaining stable also at very high temperatures, up to 150 degrees C. This results in good accuracy of the LED current over the temperature range. Depending on the LED current and the input-output difference, the internal MOSFETs of the TS19503 can dissipate quite a bit of power. Critical here are the exposed pads of the MSOP10 package, allowing the designer to use thermal vias to get the heat away from the IC. PCB layout in the datasheet also includes some tips to reduce EMI. TS19503 is also popular in non-automotive applications, especially in LED drivers that use a two-stage design. An intermediate DC line eliminates all flicker and can be converted to a well-regulated constant LED current. The 75-volt process is also an advantage here. Long LED strings can be attached to maximize the light output. And the device offers a lot of design flexibility. You can attach 1 up to 20 LEDs, keeping the same IC. Here we are designing a 500 milliamp constant current LED source. Yes, the IC works well with a load of 1 LED and very high input voltages. Current remains well regulated, whether you attached 1 or 15 LEDs. Dimming information is available in a dedicated user manual. The product offers PWM and linear dimming. As you can see on the linear dim graph, the dim pin operates from 0.1 to 1.6 volt. A simple circuit with an NTC can control the LED current in automotive and other applications should the ambient temperature become too high and the LED can be destroyed. Let's go into detail on the control loop. It looks straightforward and easy. Current is sensed via sense resistor on the CS pin. And this voltage will drive the on-chip MOSFETs at the LX pin to keep a well-regulated current. When we look at the internal operation, however, we can detect the hysteretic control. The sensed voltage VSN is converted into a sawtooth wave on the power side with two threshold levels. These levels control the internal MOSFET and the LX pin. They produce a fixed peak-to-peak current with a variable frequency. Control loop has EMI advantages in the circuit. Included in the datasheets are the EMI test setup and results. TS19503 meets the automotive HYSTERETIC Class 5 standard and passes with a good margin. The circuit to do so can be simple with a low-cost bill of material. A spreadsheet is available helping you on designing with the TS19503. Your inputs include the input voltage and the number of LEDs you want to drive and their output voltage. You also set the current and you choose the inductor to match your needs. And the spreadsheet will provide you with all the timing information and the duty cycle. And it performs also a quick thermal check. A demo board is available for an 800 milliamp 3 LED output configuration. You can see the current regulation for an input voltage varying from 12 to 60 volts. It remains stable over the wide input voltage range. And finally, in summary, the TS19503 is a versatile DC-DC converter. It is automotive qualified, uses a high voltage CMOS process, offers good EMI performance, allows flexible design with various LED loads. For more information, contact us using the web, or your distribution partner, or your TSC sales contact. Thank you.